Hello class. In this lecture, I will talk about hypothesis testing using ZStat. And I will emphasize on one tail. So ZStat, we have previously discussed, this is used when the population variance sigma is known. Population standard deviation or variance sigma is known, and the sample size is greater than or equal to 30. And we have previously discussed two-tail, in which we evaluated both sides of a normal distribution curve. In one tail, we will be evaluating one side of a normal curve. So I will take an example and try to explain how we do one tail using ZStat. So example, so our problem is a president of a university claims that the weight of students in the university is at most 160 pounds. So the difference between so we did the same problem in two tail. The difference between one tail and two tail is this at most. In two tail, it was at most was not there, so it was exactly equal to 160. That's the reason we used this is in two tail. When at most was not there, our null hypothesis was mu is equal to 160 and alternative was mu not equal to 160. So we were evaluating on both sides of a normal distribution curve, and we were saying we can disprove the precedent if it is less than 160, and we can disprove the precedent if it is more than 160. But in this case, uh, the president says at most. So that means overall the university weight is at most 160. So again, in hypothesis testing, the first step of hypothesis testing, so this is our solution for this. So the first step of hypothesis testing is to what's that the first step of the hypothesis testing is to define your hypothesis. So here our H null and we have H alternative. So the president is claiming at most of 160, so mu should be greater than or equal to 160 pounds. So again, in my previous lecture I told you that this null hypothesis should always include equal sign. so it should always include equal sign. So the less than or equal to 160 means it includes 160. And then the next alternative would be mu greater than 160 pounds. So once we define our hypothesis, then we conduct an experiment and get our sample. So we will take some students from the university and measure their weights. So this all will be given. So if we sample 49 students and we obtain our the mean of that sample as 158, and the standard deviation is known, and this is equivalent to I think 4, and then we wanted to determine at significance level of significance level means alpha 0.05, or the other way of saying this is 95% confidence interval. So this all will be given. So the second step of hypothesis testing is to conduct test statistic and compare it with critical value. So the test statistic, z test statistic value formula would be z is equal to x bar minus mu sigma by root n. So why we are using z again? If you see our sample size is 49, so n is greater than or greater than 30. So the n is greater than 30 in this case, and then sigma is known. So these two together suggest that we use z stat. So our x bar is 158, and then our mu is again the manager, the president, not the manager, claims that it's 160, so our mu is 160. So we'll just take this value and substitute here. So this is 160 divided by sigma is given as 4 over square root of n is 49. So this is going to give us a z value of negative 3.5. Now the critical value, this is a one-tail problem, so the critical value would be z alpha, rather than in two-tail we were using critical value z alpha over 2 because we were looking on both sides of the normal distribution curve. Now it is z alpha. So alpha is given as 0.05, so we are looking for z 0.05. So what this means is actually I can plot this in a normal distribution curve. So I will go to a normal distribution. I will draw a normal curve. So this is how a normal curve looks. And then since the president is saying at most of 160, so if this is the curve, the population mean curve, mu is equal to 160, and then they are asking us to do for it 95% confidence or significance level of 0.05. So at most means on the right side of the curve. So this is the significance level 0.05. This is our alpha. So what when we say at most anything left of this curve, this all, since 160 falls, whatever the president is claiming on this side, our null hypothesis, our H null, we do not reject H null. In other way, it means your H null is true. That means the president's claim of 160 mu less than or equal to 160 is true. So this was your H null. So anything above this, so this area, anything above this point is reject H null. So we kind of reject H null. This is the area where we are saying it will be more than 160. So here alternative, this H null, which is mu less than or equal to 160, this will be false. So when we say this is false, that means we can inherently say that alternative is true, that is H null mu greater than 160. So this is true. So at this point I wanted to determine what is z values. So if you see, this is 0.05. So one of the ways is because our z table gives left of the curve, gives left this the rest, since this whole area is 0.05, this area would be 0.95. So I will go and look for z 0.95. That's one way. The other way is since I know this is 0.05, I will just look at 0.05 on this side. So I will get negative z alpha value. So I can just do positive of that number. Both are same. Or you do z at 0.05 and then you convert that negative value in front to positive. So that is what can be done. So that's your choice what you want to do. So we will just use z 0.95 and go look for in our z table z 0.95 value. Again, I'm going to my business statistics canvas page and go to modules, and then go to calculation aids, look for statistical tables, download statistical tables. I will do enable editing. I'm currently in Poisson table, so I will go and look for z table, and now I am looking for a probability of 0.95. So let me see where is 0.95. So 0.95 is somewhere here or here. So 1.64 or 1.65, whichever you want. So I will take 1.64. So when I looked for 0.95, that is directly giving me this value. So this is uh, point z.95. So this was wrong. So that is going to give me 1.64. So the value here this line would be 1.64. So that is our critical value. So 1.64 is our critical value, and then we are looking for our z value using z-stat, so that we got negative 3.5. So which side of this 1.64 will be negative 3.64? It will all obviously be on the left side somewhere here. So this might be negative 3.5. So if you see, it lies in do not reject H null. So we are saying do not reject H null. So do not reject H null. So which means this is true. So we are not able to reject it. So this is true. That means the president's claim that the weight of the students in the university is less than 160 is true. So you can provide a statement saying there is sufficient evidence to claim that the weight of students is less than 160 pounds at 95% confidence interval. So that's how you will be solving this problem. So I will try to solve the same problem using our calculation aids in Hawk's Learning and see if we can solve the problem. So our hypothesis was H null is mu less than or equal to 160. So I will copy that. So this is very important to solve these kind of problems, the hypothesis. And then our alternative would be mu greater than 160 and our data. So this will be given. So n is given as 49 in our problem. X bar was 158. Sigma is known and this is equal to 4. Our alpha significance level is 0.05. So this all is given. So again because this n is equal to 49, this is greater than 30, and this is known. We will be using z stat, which is known variance in our sheet. So I will go and download our calculation aid of chapter 10. So this is chapter 10. So which sheet to use? Mostly we will be using mean. mm, we will be using uh, mm, we will be using mean, test, known variance, and you see this is, we are trying to give using alternative, which case to select. So what is our case? Mm, so our alternative is greater than, mu greater than, so I will go here mm, and select greater than. So this is, so this is the one I will be using, because mu greater than 160 is what was our alternative hypothesis. So population mean in this case is 160. So I will go and type in 160. And then population standard deviation uh, in our case was let me see, is 4. So I will type in 4 there. So this is 4, and then sample mean, I think it should be 158. X bar is 158. So that's 158. Alpha, the significance level, let me check what is alpha. Alpha is 0.05. mm, 0.05, and then sample size is 49. So we got our test statistic, that is negative 3.5. 1.64 is our critical value, and we say don't reject. So that's how we will be solving this kind of problems. So let's now try to solve a Hawk's learning problem on this. So we have a manufacturer of chocolate chips who would like to know whether its bags filling machine works correctly at 448 gram setting. It is believed that the machine is underfilling the bags. So this is something new happening. They are underfilling. Uh, in uh, uh, in reality, it should fill 448. So it's underfilling it. That's something new happening. And then a 40 bag sample has a mean of 445. A level of significance of 0.05 will be used. Is there sufficient evidence to support that uh, the claim that the bags are underfilled? Assume the variance to be 196. So I will go to the Word document and note down all these values. So the first thing is they are saying whether the bag is being underfilled, and it should correctly fill 448. So our mean mu. So this is a Hawk's learning problem. So our mu is how much? Let me cross check. Our mu is 448. So mu is 448, and then they are saying the bags were underfilled. So that's a new system. So that's something new happening in. So that means mu should be less than 448, and alternative would be mu greater than or equal to 448. So usually if they say underfilling, something like that, you are putting it in alternative, because this will always have equal sign. So, and the other thing is something new is happening. Usually in reality it should fill 448. So that's the reason why we wrote our hypothesis like this. And now what is given. So let's see what's given. So given is a sample of 40 bags had a mean of 445. So our sample n is 40 and x bar is 445, and then what else is given? A level of significance of 0.05 will be used. So 0.05 significance level, alpha is 0.05, and then we wanted the variance. So let's see. So again, assume the variance is known to be 196. So the variance is known. So they gave us sigma square, which is variance, is 196. So we needed standard deviation square root of 196. So this should be, I think, let me calculate it. This should be, I will go to an Excel sheet and calculate it. Square root of 196. So let me see, is equal to, I think it should be 13 maybe. Square root of 196 is 14. Okay, so it is 14. So we have everything, so we have to just key in these values. So again, in our case, if you go, I will download a new calculation aid. So chapter 10, calculation aid. So again, I'm downloading this again and again because while videotaping it becomes difficult to type in again on the same used spreadsheet. So we are in proportion test. We wanted to go to mean test known variance because we have our variance known. So this is given as known and n is also greater than 30. So we will be using that sheet, known variance sheet. So I will go here, and then we are looking for which case to use, whether case 1, case 2 or case 3. So I go and look for what hypothesis I wrote. So this one, the alternative is mu less than 448. So this is less than sign, so I will go here, and this one says alternative mu less than. So what is, I will use this one, case 2. So what is the population mean? Population mean is 448, that is given, so you can use this. So 448, I will go to 448, and population standard deviation is given population standard deviation is 14. So I will enter 14 here, and then sample mean is sample mean is 445, and the significance level alpha is given as 0.05, and then sample size is sample size is 40. So again our test statistic value is minus 1.355 and our critical value is negative 1.64, and they say don't reject. So when they say don't reject H null, so they are saying referring to H null. So we don't reject, that means this statement is true. So so let's read the both statements. So that means they are overfilling or they are filling according to what is what it should be filled. So let me go to Hawk's learning and look at the statement. So there is not sufficient evidence to support the claim that the bags are underfilled. Uh, this is true because the bags are being filled uh, like at 448. That is what our analysis says. So we don't have evidence that it is underfilling. So we will submit this, and that's how you will be solving these kind of problems. This concludes my lecture on one tail. Thank you.